Hi students, welcome to Preliminary Chemistry and the water topic. This is video number 19 on dilutions. So we've been looking at concentrations and how we calculate concentrations and also how we use our formulae to calculate the mass of precipitates. But sometimes what we're required to do is to dilute solutions, to change the concentrations of solutions. Now in order to do that, we need to work through a couple of quick steps to just identify how we may calculate these changes in concentration. The first thing we need to talk about is how to prepare a standard solution, and you will be doing this in class. To do this, you'll be using this device here, which is called a volumetric flask. One of the most important things about the volumetric flask is this little line here. Standard solutions are just solutions which have a known concentration. There are different types of standards, and we will talk about this in the HSC course next year. But for all practical purposes at the moment, a standard solution is just one in which you know what the concentration is. The general procedure involves weighing accurately a certain quantity of a solid. That could be something like sodium hydroxide or sodium carbonate, something like that. You add it to a particular flask, like one of these volumetric flasks over here, and then you rinse as much of that as you possibly can. Make sure that all of the solid is transferred to the volumetric flask, and then fill it with water so that the meniscus, the bottom of the meniscus, is sitting directly on this line. And you wouldn't want to make sure that you can see it as it's shown in the diagram here, like a ring. You'd want to make sure you were looking at it on eye level, so all you could see is just a single line. When that happens, then we know that we have exactly what is marked on the volumetric flask. That is a 100 ml solution, in this case, of our solid. Now, once we've prepared a solution, we can then change the concentration of that solution just through dilution, just by the addition of distilled water. The key to calculating dilutions is that in most cases, when we're doing this, the number of moles is actually going to stay the same. So all we're going to do is transfer a certain amount out in order to make sure that we have the same number of moles in each of our two solutions. Just one, as the concentration goes up, the volume of that, the number of moles to contain that will be less. And as we add more water, that is, the volume increases, the concentration will decrease. So there's an inverse relationship here. In fact, we know that the formula for our concentration, our number of moles, is equal to CV, or concentration is N on V. And therefore, if we look at the concentration or the number of moles of our solution before we do our calculation, then we know that if I is initial, then the number of moles initially is going to be a multiple of the initial concentration and the initial volume. Likewise, in the final case, our final number of moles will also be equal to the final concentration multiplied by the final volume. Now, in the case that both of these two are identical, then CI times VI equals CF times VF. Now, this is often written CI/VI equals CF/VF. You can also see it written as C1V1 equals C2V2, just a multiple of each of these at some point in time, based on the fact that the number of moles is the same. The one thing that I would just caution you about here as we look at an example is that the final volume will actually be the final volume of the solution and not necessarily the amount of water that needs to be added. So let's look at an example to pull that apart. So if we have a volumetric flask containing a 1 ml solution of sodium hydroxide and we wanted 250 ml of a 0.2 molar solution of sodium hydroxide, what volume of the original solution do we need and how much distilled water should be added? Well, hopefully you're realizing that we're actually going for a 5-fold decrease in the concentration. So there's going to be kind of a bit of a clue here. But anyway, let's look at the fact that if we have C initial, V initial equals C final, V final, and look at where we have. So we've got our volumetric flask, which contains a 1 molar solution. So that's nice. So CI, I'll pop over here, CI is 1 mole per litre. The final concentration we would like to be 0.2 molar, and the final volume we would like to be 250 mils, which we need to convert to 0.25 liters. The initial volume is what we don't know about. Okay, so therefore in this case we're going to have 1 times VI is equal to 0.2 times 0.25. So this is 1 time, so this is going to be VI is equal to, and 0.2 times 0.25 is going to be 0.05 liters, which is equal to 50 mils. So the first part of our question is, what volume of the original solution do we need? So we need 50 mils, therefore 50 mils of original solution. But we also notice that we want to, that we're asked how much distilled water should be added. Now, if the final volume is going to be 250 mils, then the amount of distilled water added will need to be 250 mils minus the 50 mils of the solution that we have, which means we're going to have to add 200 mils of distilled water. And that's our answer. This is the way to sort of work through these examples. And again, I'm sure you do plenty of examples of these in class. Thanks for watching.